Hey guys, BuildZoid here, and today I'm going to be sharing some of my thoughts on the Ryzen 7000 series, as well as sort of my content plans, and we're going to talk a little bit about motherboards as well. So anyway, I'm going to assume that you watched the AMD Ryzen 7000 announcement video, and the basic gist of it is we have a 16-core, 12-core, 8-core, and 6-core CPU. They clock very, very, very high, which is kind of exciting. Like, the funny thing about clock speed is it doesn't directly translate into performance, but who doesn't love looking at big numbers, even if they don't necessarily mean anything, like on bulldozer CPUs. But anyway, so yeah, we've got, high core count, very high clock speed CPUs. They're supposed to have a slight, there's supposed to be also an IPC improvement, so these should be very, very, very fast. So that's exciting. In terms of pricing, the 7950X is going to be $700. The 7900X should be around $550. The 7700X is going to be $400, and the 7600X is going to be $300. And the cool thing is, so the 7950X is actually cheaper than the 5950X was at launch. I guess we have Intel to thank for that, because now that Intel has E-cores, they can finally compete with AMD when it comes to Cinebench and other highly multi-threaded workloads. And then for the rest of the lineup, the pricing is actually not really, it's not improving, right? The 7900X is, as far as I know, at the exact same price that the 5900X launched at. And the 7700X is slightly cheaper than the 5800X, but $400 for an 8-core CPU is still a lot of money for an 8-core CPU. And the 7600X at $300 is exactly the same price as the 5600X was, which was also, as far as I know, $300 at launch. So, yeah, AMD is launching these with a sort of very... basically, this is high-end CPUs. We have, high-end gaming CPUs, high-end workstation CPUs. We don't have a mainstream Ryzen 7000 CPU or a low-end mainstream, low-end 7000 series CPU. That's just not what AMD is launching, which kind of makes sense considering that the only chipset that's going to be available initially is going to be X670 and X670E, which are both going to be very expensive. Yeah, that's probably why the CPUs, there isn't a low-end Ryzen 7000 option. That's potential. The thing is, just because just because new CPUs have come out doesn't mean you need to run out and buy them, right? So I don't really see a huge issue with what AMD has decided to do here. I do think the 7600X is a very situational CPU. The same is actually true for the higher end ones. Most people don't need a 16-core CPU. Most people don't do video editing. Most people don't do, rendering or run virtual machines or host servers or anything like that. So most people do not need a 16-core or a 12-core. An 8-core or a 6-core, that's debatable, but there are cheaper 8-core and 6-core CPUs that still have a ton of performance. CPUs like the 12600KF and the 12700F. Right? This is a $300 CPU with 8 P cores, 4 E cores. So, if you don't need the absolute peak of single-threaded performance, which is what AMD is promising with their Ryzen 7000 lineup, at least until Intel comes out with 13th gen, right? There are definitely much more cost-effective options than what AMD has for, the bottom end of the 7000 series stack. So these two CPUs down here, these are very situational. Right? The way I see something like the 7600X is, if you have a 3090 Ti, the 7600X might make sense. If you're playing at 1080p. If you're playing at 4K, you don't need a 7600X, unless you're playing some kind of MMO or something, because there are a lot of games that, it doesn't matter what GPU you have, you're going to be eternally CPU bottlenecked because they're just very, very badly, and it's not necessarily even badly optimized, because I'm not aware of a single MMO that runs well once you get 100 people on screen. That's just not a thing in my experience. I've played quite a few MMOs, and the performance always tanks once there's enough people on the screen. That's just an inevitable, an inevitable fact of life if you play MMOs. It's oh, there's 100 people on screen, the FPS is gone. There's nothing, I've never played an MMO where that doesn't happen. So that's kind of the thing. And in that scenario, yes, a 7600X would actually make sense even if you had like an RTX 2080 or something, or a 1080 Ti even, because you're playing like there are games and there are workloads that just do not care about, more cores, and they're only single threaded. And in that kind of scenario, a 7600X could make sense. The 5800X 3D could also be an alternative. The 5800X 3D is actually more expensive than a 7600X. So, that leads into you need to, this is a very situational CPU, is what I'm getting at. Like, it's not a CPU that makes zero sense, but it is very expensive for what it is. And so you need to have a very good reason, in my opinion, to buy a 7600X. Right? Especially when we consider DDR5 pricing. So right now you can get like a proper set of DDR5 for about I'm in the UK right now. Let's switch this to the US. For around is that 2x16? Yeah, you can get for around 100. Well, the thing is, this will still do 5400. That's the nice thing about so I wouldn't have a problem with buying this. This should still hit like DDR5 5400. This should hit 5400. This should actually, with Kingston, there's a decent chance that you're gonna get a Hynix kit even in like a really really low end bin, and so you might be able to do like 6000 or even you're probably you're potentially gonna be able to max out a Ryzen 7000 memory controller, even on a kit that's like this right here. You could also get Micron, and then it's going to get stuck at 5400, but that's kind of, that's still, that's not, I don't think that's the end of the world, and that's some nice overclocking headroom, even if for the price. So you can get DDR5 that's for like $150 to like $160 at this point. So the CPU's $300. For motherboards, the options are kind of difficult. This right here looks like it should be under $300. I'm not sure that it'll be as low as 200. I kind of doubt that, but maybe 250. The reason I say that is because as far as I can tell, this is a 6-layer PCB based on the layer count indicator over here. This, funnily enough, the Gigabyte website says that it's an 8-layer board, but that wouldn't be the first time that the Gigabyte website had a typo on it when it comes to PCB layer counts. And that layer count indicator really does look like a 6, because that's 1, 2, 3, and then on the back we should have 4, 5, 6. So I don't know how this is supposed to be an 8-layer board, considering that the indicator is for 6 layers. Anyway, ASRock has this thing, which also looks like it could be under $300, and then the MSI has this, which also looks like it could be under $300. So I don't think, basically with X670, the low end, X670 versus Z690. Z690, you can get motherboards as low as $200, and they're still good motherboards. Whereas with X670, I don't think they're going to go as low as 200, but I also don't think that all of the motherboards are going to be above $300 or above $400. If Gigabyte is charging $400 for this thing, I think they've gone insane. Same goes for ASRock or MSI. This does not look like a $400 motherboard. I don't know why this should cost $400. So 300, I could kind of see that, but 400 would be insanity in my opinion. For a board like this. So a sort of platform cost for a 7600X, we're going to be talking on the low end, maybe $650. On the high end, because it'd be 300 plus 300 board plus 150 for the memory kit, $750, right? So 650 to 750 for a 7600X. Whereas if you were going with a 5800X 3D, you admittedly could get a 5800X 3D onto a $100 motherboard, and it's going to run just fine because it's an 8-core Ryzen 5000. It doesn't pull any power. That's just kind of how that works. Actually, none of the Ryzen CPUs really pull any power. They're 5000 series. They're very power efficient. Well, it's not that they don't scale to insane power consumption. Let's put it that way. You can't really. It's not like Intel CPUs where at 4.8 gigahertz. You get really good performance and power consumption, and then you turn it up to 5.2 gigahertz, your performance goes up by 10%, and your power consumption doubles. And that's literally what happens. Um, well, actually, it's not quite doubles, but it gets pretty close to doubling your power consumption if you go from like 4.8 to 5.2. But on a Intel 12th gen, and with Ryzen, that's not really a thing. Like, you can't really go and take, well, especially on a 5800X 3D, like, you can't overclock that CPU, so you're not going to be doing that anyway. So you can run a 5800X 3D on like a $100 motherboard, and the kicker with the 5800X 3D is, thanks to all of the L3 cache, it really doesn't care about memory performance, because the whole point of having a bunch of L3 cache is that you avoid using the RAM as much as possible. And so the end result of that is that you can go and, use like an $80 memory kit, still 32 gigs, right? And with a 5800X 3D, you'll be getting like amazing gaming performance, even if your RAM is technically like garbage tier memory. It's like, it doesn't matter. The CPU doesn't really have to, like, the CPU isn't going to be hammering the memory system because it has all of the L3 cache. So the 7600X is, like, the biggest competitor for the 7600X, in my opinion, is a 5800X 3D. It's not something like a 12700F, which, similar price, much higher core count, or a 12600KF, lower price, much higher core count. Like, these I don't think are competitors for a 7600X, because if AMD claims the 7600X outperforms a 12900K in gaming, right? So if you're playing a game that's very single-threaded, which is where a 7600X would shine, or a 5800X 3D would shine, a 12600KF is going to do literally nothing, right? Like, you're going to buy a 6-core CPU with 4 E-cores that, if anything, you might want to turn the E-cores off so that you can raise the ring clock, because your horribly single-threaded, memory-bound game needs all the ring clock it can get, basically. Right, and so that's kind of the thing with something like a 12600KF versus 7600X. It's kind of like making arguing over, should I buy a 3900X or a 5600X for gaming? And it's like, you should buy a 5600X because a 12-core CPU isn't going to, like, the extra cores on a 3900X are not going to give you extra gaming performance. Similarly, a 12600KF is probably not going to beat a 7600X in gaming. However, obviously the total platform cost for a 12600KF is way lower. Same goes for a 12700F, right? You can get a $200 motherboard for this CPU, so that's $500, let's say 520 motherboard plus CPU, and then $80 to $100 on the memory, and for like $620, you've got way more cores than with a 7600X. With a 12600KF, you're under $600 to get the same amount of like memory, lower single-threaded performance, but more multi-core performance. And so that's kind of the thing. So the 7600X is in a sort of awkward scenario where it's like, there are workloads where a 7600X definitely makes sense. This would be, but this is also like the workloads where like a 5800X 3D is an option, which the 5800X 3D is, I think, still $450. Let's just pull it up on PC Part Picker. So yeah, the 5800X 3D is, it's actually $400. Yeah, so that makes it really hard to justify a 7600X right now. Because this on a $100 motherboard, like, that's going to be $600 for CPU motherboard memory, which is just going to be less than what you're going to spend on a 7600X. So yeah, this right now, I don't think a lot of these should be selling early. Now, admittedly, there are certain workloads that that are very single-threaded, but don't benefit from a 5800X 3D, right? Because the 5800X 3D doesn't actually have a ton of single-threaded performance. It eliminates memory bottlenecks, which is not the same thing. A lot of horribly optimized single-threaded workloads are very memory bottlenecked, but not all single-threaded workloads are inherently memory bottlenecked. That's, there's a difference between the two. And so the 5800X 3D, like the choice between a 7600X and a 5800X 3D and like a 12700F, 12600KF really depends on knowing what it is you're trying to do, right? If you're playing a game or you have a piece of software that's like very old or just very single threaded and it doesn't hammer the memory system, 7600X all day, every day. Whereas if you have a workload that does hammer the memory system, you get a 5800X 3D. And though I guess maybe the 7600X has enough optimizations in its memory controller and like, well, I doubt it. There's just not really a workaround for how, like, no amount of memory controller. I don't like. I doubt that there's any amount of memory controller optimization that can be done to circumvent the benefits of just having way more L3 cache. Like, yeah. So I don't think. Yeah, I really don't think there's any way a 7600X could beat a, like, where the 5800X 3D does well. I don't think a 7600X has a chance, like, in those kinds of workloads. It won't do badly, but yeah, like, there are workloads where the 5800X 3D just absolutely dominates, and there the 7600X just shouldn't really be able to compete whatsoever. So yeah, this is a very situational CPU is what I'm saying. Now, the funny thing is, if you know for a fact that the workload you're going to be running does benefit from just a ton of single-threaded performance, again, going based on AMD's claims, obviously wait for benchmarks. Don't just run out and buy a 7600X on launch day. But if you know for a fact that you have a workload that isn't memory bottlenecked, but is very single threaded, then yeah, a 7600X will make a ton of sense. Like, it'll solve your single threaded bottleneck is basically what it'll do. Right. So yeah, but it is a very situational CPU in my opinion, because it is very expensive. If it was cheaper, you could make the argument that, like, you just buy a 7600X as the sort of the default high performance 6-core option. But as it is, like, it's very expensive. Like, there's really no way around it. And so now you need to justify, and so, you kind of need to justify the purchase. Like, there's no point buying a 7600X if you play AAA games at 4K. Like, this is not really going to do anything for you. If you play some ancient MMO or something, then it might be better than a 5800X 3D. It might not. But yeah, I also don't think, like, it's a competitor for, like, a 12600KF or a 12700F. Now, the 7700X is in a similar situation, in my opinion, because this is an 8-core CPU. That's $400. Is this going to be, like, we obviously don't have, wait for benchmarks, but the 7700X making sense as a purchasing decision is really dependent on, can the 7700X beat a 12700F in multi-threaded? Because if it's like equal, well, no, if it can't, then this is, because the only reason you would get a 7700X over a 7600X is because you need more multi-threaded performance. In which case, you would probably even benefit from a 12700F. Because the thing is, a lot of applications, like, you either have applications that are really not very multi-threaded at all, and then on the other end, you have applications that scale up to, like, ludicrous core counts, right? Like, up to around, like, 32 cores is not that uncommon once you get into things that are actually multi-threaded. And so, in that scenario, the 7700X is a bit awkward, because it's like, it's not really that many cores, and single-threaded performance-wise, it's basically the same as a 7600X. Though, looking at those boost clocks, the 7600X is probably going to have the most overclocking headroom, especially since it's going to run less hot than the higher core count CPUs, right? Like, it just produces less heat. Now, obviously, it's going to, like, based on the boost clocks, it also probably uses worse silicon, but the current trend in like clock speed and frequency, well, for frequency and like in modern CPUs, is that everything is getting more and more thermally limited. So max clock on like a 12th gen Intel or a 5000 series Ryzen is primarily limited by how low you can keep the operating temperature. Right? And so a 7600X with a lower power consumption is going to have a bit of an advantage in that department over the higher core count CPUs. And so that could make up for the difference in the silicon quality to some extent. Anyway, so the 7700X is like, yeah, it really depends on if this has enough multi-threaded to justify the $400 price tag, because otherwise it's like, this is like a lot of multi-threaded performance for $300, right? So yeah, so that, like Ryzen 7000 is very, very situational, I think, for the lower core count CPUs. And then you get to the 7950X and the 7900X, and it's just like, that's a 12 core. You know, like that's going to comfortably beat a what is it? Like a 12 core where half the what is it? 2/3? No, 1/3 of the cores suck. Yeah, like obviously a proper 12 core is going to beat an 8+4 thing. But also this is like $550. And this is a CPU where it's like, you know, you have multi-threaded workloads. You're like video editing, rendering, virtual machines, servers, code compiling maybe. I don't know. I don't really do a lot of professional work on my personal system, so yeah, don't really know of a lot of good examples for that, but basically, if you know you need a lot of cores, then these make a lot of sense, right? Assuming that you don't need like a straight up Threadripper or something. But again, Threadrippers are very, very expensive, so like these do have a like cost per core advantage over some of the really, really high core count options out there, right? So if it's like, I need more multi-threaded, but I can't quite get a Threadripper, then these do make some sense. Like, I'm wondering, like, AMD made a statement that they're not going to have short, like, supply issues with Ryzen 7000, and if I had to guess, it's because the prices are so high. Like, they've really made a lineup of CPUs where it's like, so we have potentially single-threaded domination at $300, which is like, well, if you need that, that's cool. If you don't need that, there are much cheaper options out there. Right? Like you could even go below a 12600KF. You could go like a 12400F, and that is a very good gaming CPU. And you know, if you don't have like a super high-end GPU, or you don't play games that are extremely old, or extremely single-threaded, I should say, because it doesn't need to inherit, like it doesn't necessarily even have to be old, because a lot of indie developers, you know, they're going to release a new game. And it's going to be horribly single-threaded because they're an indie developer. They don't have the time to optimize their game to run on more than like 4 cores. That's if they get it optimized for 4 cores in the first place, right? So this is kind of the, like, this is a very situational CPU that, yeah, it really depends on what you're doing, and it's very expensive. And the same is basically true for a lot of these. It's like, I'd say you kind of need to know what you want from these in order to get them. It's not kind of like Intel 12th gen, I feel, is a sort of like, because the prices are so much lower, 12th gen Intel is a lot less of a like, oh, is my workload actually going to benefit from this? Because like a 12400F is like $200 or something. I should just pull it up. I should have pulled that up in the first place. Yeah, it's under $200, right? Like, so, and this is a, like, you know, it's clocked way lower, but this is a very good CPU in terms of general performance. So, yeah, like, AMD's high prices is like, makes it, like, yeah, you'd literally be spending twice as much on your CPU if you, and that's the thing, is like, there are scenarios where a 7600X is going to absolutely destroy something like a 12400F. But if what you're doing with your system is not that scenario, don't spend $300 on your CPU and then $150 on DDR5 and then $300 or more on your motherboard just because AMD released a new CPU. Okay, that doesn't make any sense. It doesn't. Okay? At the same time, it's, you know, like I'm excited about progress in terms of, like, single-threaded performance and that kind of thing. But then again, like one of the games I play on a relatively regular basis is the definition of a horribly optimized MMO from 2012. So, like like back in 2012, the game ran at like 40 to 50 FPS in a big fight. These days, it runs at like 80 to 100 FPS in a big fight. So, there's been some progress, but I wouldn't mind more for that specific application. I still wouldn't buy a 7600X though, because for my daily system with the with the work I do prefer having a few more cores. Though honestly, a 7700X would probably give me about as much multi-threaded performance as I need. But yeah, that's like, these are situational, very situational CPUs for like general purpose. But they are very fast. They're also very expensive. So you kind of, like, I wouldn't buy a 7600X unless you have like a 3090 Ti or something, right? Like, that's kind of the thing with the 7000 series, is like very, very conditional in my opinion, until the prices drop. Like if the 7600X was $200, then it would be a no-brainer compared to a 12400F or a 12600KF, or if it was 250, right? Like if it was 250, then yeah, I'd get a 7600X. Actually, you'd still have to spend extra on the DDR5 and the motherboard. Once the B650 motherboards come out, it might be a lot more interesting as a CPU, but right now I really think very situational CPU. Very, very situational. Then again, I might be wrong, and like we get benchmarks on launch day where the 7600X has the same multi-threaded performance as a 12700F, and then it's like, okay, actually just get a 7600, like, and that would justify it. If the 7600X was able to beat a 12700F in multi-threaded, then, yeah, I wouldn't have a problem with the $300 price tag, because that would also mean it has just ludicrous amounts of single-threaded performance. But I kind of doubt that's going to happen. So, yeah, these are weird CPUs. Anyway, I am very excited about the 7950X, though, for impractical reasons, the best reasons. See, the thing is, a lot of my favorite benchmarks don't scale past 16 cores at all. So this right here is 3D Mark Vantage. It's a very old benchmark. I think it's DirectX 10. And this benchmark has a CPU test, and that CPU test affects your overall score quite heavily. It's a GPU benchmark, but there's a CPU test in it. And this CPU test scales up to 16 threads. Exactly 16 threads, which means if you run it on a 5950X, you disable your SMT or you lose a bunch of performance. If you run it on a 12900K, you disable your hyperthreading and keep your E-cores turned on so that you can get, the highest possible CPU score. Which means a 7950X is going to I can't wait to see what the 7950X does to 3D Mark Vantage. Like, that's the main reason I'm excited about this CPU, is because 16 cores, turn off the SMT. It might do like Vantage's CPU test isn't that heavy, so you might be able to run it at like 5.3, 5.4, maybe 5.5 on water cooling. And it's just going to destroy this benchmark. And I can't wait to see that. And then there's also benchmarks like 3D Mark TimeSpy. The CPU test in TimeSpy is also extremely is also up to 16 cores. The Firestrike test goes up to 32 threads. So 16 cores with SMT should be very very good for that as well. So yeah, I'm very, very excited for the 7950X due to its applications in like competitive overclocking. As a practical CPU, it really depends on what you're doing. Like this isn't a CPU that it's like, oh, I want this because video editing. No. It's literally just like, I want that because Vantage. Like, I think there's a pretty good chance that 13th gen Intel is not going to be able to take back the first top score for Vantage, unless 13th gen Intel, because Vantage is so old that it is extremely CPU single threaded in terms of FPS, because the benchmark runs at 300, 400 FPS, right? And you actually see that difference right here with the 12900K versus the 5950X, right? Is the 5950X is very competitive in the CPU score against the 12900K, but the 12900K demolishes the 5950X in the GPU score because the 5950X just doesn't have the single-threaded performance to keep up with a 12900K, especially when that 12900K is at 6.7 gigahertz. So 13th gen versus 7000 series in Vantage is going to be very interesting because this benchmark is sort of a really nice mix of like you need a lot of cores, but you also need a lot of single-threaded performance because it just runs at stupid FPS. And mind you, this is on a single RTX 3090 for both of these tests. So yeah, this like I'm excited to see what the 7950X does for Vantage and Time Spy and Firestrike and like also 3D Mark 11, but I don't really like 3D Mark 11 as a benchmark because I suck at it. So, yeah, but yeah, so that's the main reason. Like, I'm really excited for that CPU. The rest of the lineup is it's kind of situational. I might be able to get a review sample of a 7950X. If I don't get a review sample of a 7950X, I'm just buying it. Like, yeah. Like, I really, really like my 5950X. I can't, because of how it does in, multi-threaded benchmarks, I kind of can't wait for the 7950X for the same reason. But from a practical perspective, the 7000 series is a very, situational. Like I've been saying the whole video, it really depends on what you need. If you don't need a bunch of single-threaded performance, the 7600X doesn't really make a lot of sense because it is very expensive for being just a 6-core CPU. If I do get a review sample of a 7950X, I'm toying with the idea of either buying a 7900X or a 7600X. Because I do think the 7600X would be very interesting in terms of like overclocking headroom, since it's the lowest core count, it's going to run the least hot. It should be the easiest to overclock, and also because it has the lowest boost clocks, it should be the easiest to overclock. Also, if some people are looking at the base clock and thinking it's very low, the base clock on Ryzen 5000 is also very, very, very low. Right? Like a 5950X has a base clock of 3.4 gigahertz, and a 5900X has a base clock of 3.7 gigahertz. And the way this works is the base clock is the frequency the CPU will not go below no matter what you do. Like if you run Prime 95 small FFTs on a 5950X, it will still be above 3.4 gigahertz. That's the point of the base clock. Which means, yeah, we're going to, this is going to run Prime 95 at above 4.5. That's insane. That's absolutely insane. That's going to be that is literally for a very if Prime 95 was like an actual workload that you ran on a regular basis, that is literally like a 30% increase in clock speed for Prime 95, which is kind of and that's ignoring the IPC uplift. So yeah, I am very, very excited for the 7950X for synthetics because in my day-to-day system usage, there's not really any practical need for a 16-core 32-thread CPU. Yeah, for benchmarking, I am very excited about that. Very, very excited about that. So that addresses sort of my general thoughts on the CPUs themselves. Like I mentioned for the motherboards, I think we should see motherboards down to around $300, maybe below that. I don't think there's gonna be any $200 boards, because I think most of the cost is actually from the dual chipsets rather so the thing with motherboards, so LGA costs more than PGA for the motherboard, so yeah, just the loading mechanism is more expensive. Also, the backplate that AMD is using for their motherboards is way more robust than basically the socket on X670 probably costs a bit more than an LGA 1700 socket, just because of the mounting hardware. It shouldn't be a big difference, but also it's going to be it's probably significantly more expensive than the old PGA socket from AM4. A higher pin count. Also, LGA sockets are literally more expensive for the same pin count, so that's driving up the cost compared to like X570 boards. You also have the dual chipset, which I don't know how much AMD is charging for the chipsets. I can't imagine that the chipsets are cheap though. Right? So that's going to add cost. PCIe Gen 5 adds some cost because the signaling requirements for it are a lot more stringent than they are for PCIe 4. And PCIe 4 already complains about risers and stuff. So, like PCIe 3.0, risers don't really do anything. Very like PCIe 3.0 really doesn't complain about much. PCIe 4.0, you have potential issues depending on what risers you're using. And PCIe 5.0 is like, now it starts complaining. Like, we've literally gone from like through-hole pins, PCIe slots to SMT PCIe slots. And then also the same thing for the DDR5, like SMT DIMM slots are actually a bit more expensive than the through-hole ones, right? And because DDR5 runs at very high clock speeds, that adds some manufacturing cost because you can't use the cheap DIMM slots anymore. So that's kind of where a lot of the cost for X670 comes from. Is just like, yeah, the higher the signaling requirements are much higher than they used to be, and that adds a bit of cost to the motherboard manufacturing, and also the thing is, I think also some of the motherboard pricing might be motivated by the CPU pricing. Right? Because if the CPUs are expensive, then it's more justifiable to have expensive motherboards. Also, B650 is supposed to be the budget option. So, yeah, I just like the initial, like, I'm not particularly excited for X670 boards because they're like, X670 is basically trying to be a workstation platform in terms of connectivity, right? Which is why you have the dual chipsets and all of the PCIe, Gen 4 coming off of the chipsets for like M.2 slots and that kind of thing, which I don't care about like at all. I don't have any M.2 drives, so yeah. But so I'm excited about the CPUs themselves. The initial motherboards, like, they're gonna be pretty expensive. I don't think, like, I've seen a lot of people be worried that like the motherboards are going to be hitting like $1,000 regularly for X670. I don't think that's going to be the case. I think we're going to have some like high-end motherboard options around the like $500 to $700 mark, which is the same as what we had for X570, right? I think no, that's not the same as what we had at X570. X570, you had like the really good motherboards started at like between $300 and $400. That's like your X570 Unify X, your X570 Master, your the original Crosshair 8 Hero. The Crosshair 8 Dark Hero is like $450 or $400, something like that. The X570 Tai Chi was like $300 or $350. So that $300 to $400 price range was like where you got the really good X570 boards. For X670, I think that's going to be now like $400 to $600 probably. Yeah, so there is definitely a like upwards shift in pricing. The thing is also AMD's increasing the power limits on the CPUs, so the power delivery is getting upgraded. So yeah, the boards are going to be expensive. The CPUs are expensive. Some of these CPUs really like don't make a lot of sense unless you know exactly what you're doing with them. But like there's a decent chance like the 7600X would actually be like if your priority is high FPS, high-end gaming, the 7600X might make a lot of sense for that. I don't consider this like a general go-to CPU. Like I really think you need to have a good reason to go for it, because CPUs like the 12400F exist, 12600KF, 12700F, right? So, yeah, and these are all like basically the same price or lower than the 7600X, which is kind of crazy considering that the 7600X is just a 6-core. But yeah, I'm excited for the benchmark scores that Ryzen 7000 is gonna produce. I don't think it is a go-to CPU option just yet because it is so insanely expensive. So, well, it's not insanely expensive. Well, depends. Depends how you look at it. But it is very expensive, and there are certainly, like, depending on the games you play, you're going to be better off buying a 12400F and spending the extra money on a better GPU than buying a 7600X. There are also some games where you'd be better off buying a 7600X and not changing, like not upgrading your GPU at all, as long as your GPU is like released in the last 5 years. So that is also a thing. But yeah, so that's kind of my thoughts. Oh, and in terms of content plans, well, I mentioned I'm definitely going to get a 7950X one way or another. If I don't get a review sample, I'm just buying that thing because I really want one. In terms of motherboards, I'm going to probably be covering most, if not all, of the Gigabyte X670 lineup. I should be getting some MSI boards. Hopefully, I'll be able to get some Asus boards. I really want a Crosshair Gene, but I should have pulled that up ahead of time. But I think everybody who's seen the Gene knows that I knows that obviously I want one. Man, why does this article suck? And their website sucks. There we go. Yeah, so obviously I want this because it's 1 DIMM per channel. At the same time, with X670, depending on the CPU's memory controller, you might be able to max out the memory controller even on a board like this. Because for Z690, the memory topologies basically all like a 6-layer DDR5 board can hit like 6000, 6200, even 6400 megabits per second. Like, that is totally doable on a 6-layer PCB with a 2 DIMM per channel daisy chain. So if the CPUs, right, because there are rumors going around that like 6000 megabits per second is going to be the sweet spot for memory data rate on Ryzen, you're not going to benefit from a 1 DIMM per channel board if the CPU's memory controller stops at 6000 megabits per second or like 6200 megabits per second, because you can do that on a, well, I guess it depends on the memory controller to some extent. If the memory controller is really, really weak, then actually a 1 DIMM per channel might make it more likely for the memory controller to actually hit that 6000 megabits per second. But I don't think it's going to be a huge difference, because that's kind of the thing. Like, how much impact the motherboard's memory topology has depends on what kind of speed you're trying to reach. So, like, during the DDR3 days, 1 DIMM per channel boards weren't massively better than, like, 2 DIMM per channel boards because DDR3 just didn't clock that high. So, the benefits of 1 DIMM per channel weren't really that big compared to, well, like, yeah, you just didn't have, like, the effect of 1 DIMM per channel wasn't really that significant. With DDR4, early DDR4, it really doesn't matter that much. Late DDR4, it matters a lot. Like, you have 1 DIMM per channel motherboards that are able to hit, well, to be fair, there's also some really strong daisy chain boards that can get still very close to like 1 DIMM per channel boards in terms of max clocks. So yeah, it depends. It really depends. Like, there's a chance that a board like this will not have any advantage over a board like this if the memory controller on the CPU itself is just that bad. I don't know yet. I guess we'll find out at launch. Yeah, and so that's kind of that. And I think that covers all of my thoughts on Ryzen 7000. I am very excited about the 7950X. The rest of the lineup is very situational. I'm going to have a ton of Gigabyte boards, of course. I should have some MSI boards. Hopefully I'll have some Asus boards. ASRock, if I want any ASRock boards, I'll have to buy them. I might be able to get the BioStar Valkyrie board. I might be able to get that. We'll see. In terms of everything else, like, wait for benchmarks. That's it basically at this point. So yeah. Thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon, which in this case is going to go, you're potentially going to be funding the purchase of the 7950X, just straight up, because that's how I, manage to purchase hardware. Or potentially a motherboard, like the Crosshair Gene or whatever. Or an ASRock board, depending on if enough people are interested in seeing an ASRock board tested. Oh, wait, no, there is one thing I forgot to mention. I am thrilled about the new IHS design for Ryzen 7000 because it exposes a bunch of the filtering capacitors for the power, like the V-core power of the cores. So getting oscilloscope measurements of the motherboard voltage regulation is going to be so much easier than for like any other CPU ever produced. Because I can, I should just be able to solder coax directly to the capacitors. And I don't have to delid the CPU. I don't have to cut a hole into the IHS. I don't have to scrape off the solder mask. I don't have to do any of that. And so, yeah, I should, assuming that I manage to get a CPU relatively quickly, right? I'm going to be able to get oscilloscope measurements for X670 very, very fast. So I'm pretty excited about that. So we'll get voltage regulate, basically I should have voltage regulation numbers for gigabyte motherboards within the first week of launch. The other manufacturers, I'm not sure yet. So yeah. Anyway, that's actually it for the video. So thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that in the description. There's also the HOC Teespring store where I've recently released some new hoodie designs. There's a link to that down in the description below as well. And I also have a Bandcamp where I post industrial noise metal stuff that you might want to check out. Link in the description again. So yeah, that's it for the video. Thanks for watching and goodbye.